am going to hand over to David, who will take us through the presentation. So thank you, David.
Good morning, everyone. Thank you very much for joining me. I'm in my shed at the moment, so hopefully we don't get too much external noise, and I hope everyone can hear me okay. Nick, if there's any issues, do give me a wave and jump up and down frantically. Okay, agenda for today. Right, so we're going to start off with some introductions. Who are Buoyant Production Technologies? Who am I? Then sort of go through what we see as the current industry context around the energy transition, bit of the pandemic, and then look at floating NUI as a technology. As Nikki said, this is something we've been developing for the last 6 years actually, and with the OGTC for the last 3. And we'll introduce some of the sort of key features that we've developed through the course of the Facility of the Future study, and then look at how they can be applied in the future and in today's sort of environment. You know, really sort of focusing on what's increasingly becoming the focus of our industry, which is how we transition through to net zero, and finally coming together with some conclusions. So to introduce, I'll start with myself. David Steed. I'm the General Manager of Buoyant Production Technologies. Now, we are a wholly owned subsidiary of Crondall Energy Consultants, and the role of BPT is to develop technology for floating production systems. Now, we've been developing normally unattended facilities for the offshore energy sector, and what we want to do today is introduce how these sort of floating, normally unattended facilities, we've coined the phrase floating NUI to cover our product lines here, present how they support the journey from where we are today through to net zero. So just a bit of a caveat here, a bit of context in sort of what's going on. Is the caveat is this is the way we're seeing things at the moment, and I would say that it's fairly overwhelming how quickly things are changing at the moment, how the dialogue is changing. Nikki and I were just discussing the fact that when we started the Facility of the Future study, the real focus was on digitalisation of offshore assets, using data and digital tools to improve operational efficiency. Now, within 2 years, those tools are almost becoming the de facto. And now the focus is, well, what do we need to do in order to reduce our emissions and to remain relevant and deliver value as we transition through to a net zero future. And what we've got here on this slide is a sort of overview of both the macro and the micro sort of situation at this point in time. On the left-hand side, we've got the sort of macro picture, which is the wholesale move from essentially a hydrocarbon energy dependency through to a net zero life cycle. You know, and on the basis that this is a transition, there's a process of going from where we are today to starting to reduce emissions, an overall transition towards net zero, an increasing mix of renewable energy sources, and then ultimately at some point in the future, a sort of net zero energy production. But as I'm sure we're all aware, as of today, the offshore energy industry is dealing with, or has been dealing with, the COVID-19 pandemic, and that, you know, frankly, demand for energy has plummeted over the last 12 months, and that obviously has had its own sort of seismic impact on the industry. So where we see the sort of the coming year is that as we emerge from the pandemic, we see demand for energy recovering as the global economy recovers. That sort of makes sense. And then reflecting on the fact that prior to the pandemic, we were only just recovering from the last shock, which was the oil price crash in 2015. We've got to understand that there has been chronic underinvestment in hydrocarbon production. And that will mean it's pretty likely that there's going to be demand for future exploration and production and development in order to plug the gap as we start to transition through towards that sort of net zero future. On the other hand, we've got this emissions focus from the public, from the regulators, from the financiers, which is going to drive project decisions. So in the nearer term, in this sort of micro picture, what we're seeing is the demand for hydrocarbon developments is actually likely to grow over the next year, but they've got to be different. They're going to have to be under the scrutiny of the public, the regulators, but probably the most challenging is that the financial institutions are really focused at the moment and moving their financial support towards away from projects which have got sort of poor GHG, greenhouse gas emission credentials. So quite a complex picture at the moment, and it's probably going to get more complex over the upcoming years. So, okay, what does that mean for offshore developments? The way we're seeing this at the moment is that in the near term, we're really the focus is on reducing emissions from new projects and from existing developments. So reducing that scope 1 and scope 2 emissions. As well as that, we're seeing the beginnings of a number of projects offshore that are looking at sequestering CO2 offshore. And we also see a general move, a sort of increasing interest in gas versus oil projects on the basis that they're not as poor from a net zero perspective. As we look into the medium term, we see the sort of the move towards electrification of hydrocarbon production projects. So we've seen this a number of times recently, and in discussions with industrial contacts, is we're seeing an increased demand from operators for studies in essentially power import from an onshore sort of renewable or low emission source to the offshore facilities in order to reduce the emissions of the offshore platforms. We see the opportunity, once we get past the initial pilot projects for CO2 sequestration, we see that expanding in the future. And as the technology develops, we see the introduction of offshore hydrogen generation, whether that probably sort of generated from renewable sources as a way of managing supply and demand levels from the renewable sources. And in the very long term, as we get to that net zero ambition, we see the sort of large scale replacement of hydrocarbon energy sources with renewables. So these sort of three sort of what we see here are really what we're seeing as the progression of the offshore energy industry, both hydrocarbon and renewables, as we go forwards in the future. And it's a transition. It's going to be a phased process, and that means that we need to be looking at the technologies we need today and the technologies we need in the future in order to deliver these sort of development objectives. Okay, so that was sort of an overview of the context as we see it. I'm just already looking at the time, and that looks worrying. Now, just sort of touching on our technology, on the floating NUI technology. I'll give you an introduction to it and look at how that sits in terms of the sort of net zero future. So starting off with the development background, I'll sort of whiz through this. Essentially, in 2014, when we started looking at floating NUI technologies, we identified a gap where fields essentially weren't getting developed, the marginal fields. These are fields that were too small to be economically viable using even the smallest of the sort of floating production units or platforms, but were too big or too complex, or the distance from other infrastructure was too great for a subsea tieback to be viable. And from that, we developed two sort of generic types of technology, a floating NUI production buoy, providing standalone production of small pools on a normally unattended basis. And that's really what we focused on with the Facility of the Future study with the Oil and Gas Technology Centre. And then on top of that was a more simple solution, just providing some form of utilities to enable a subsea tieback. So where a subsea tieback is either challenged because it lacks a utility at the well site, or whether it's simply distance, it might just need some pumping. For instance, you can provide that with a very simple buoy, operated on a normally unattended basis, remotely controlled, maintained on a sort of campaign basis, and enable a longer range, more challenging tieback to be delivered. So there are two sort of types of technology there that we've developed as floating NUI. All of our design products have been essentially underpinned by a change in design philosophy. And this is really a lot of the learning that we took away from the Facility of the Future study, which is that if we just try and shrink down a traditional platform, a manned platform concept, in order to get a sort of small unmanned facility, you don't really sort of move the needle as far as we need it to. So we started at the other end. We started with our operations and maintenance model, essentially defined how we were going to operate on an unmanned basis and how we were going to maintain the facility, which in this instance was through the use of walk-to-work campaigns. And then we developed how the design philosophies that were required in order to achieve our goals. So essentially, the real focus was around a lean design facility philosophy, really sort of trying to minimize the overall complexity of the facility in order to simplify the remote operations and minimize the manned maintenance required. What that sort of resulted in is a real focus around using digital tools in order to enable remote operation, and also to provide the sort of data-driven decision support that you require for both in terms of improving your operational efficiency, but also ensuring that you can have condition-based maintenance regimes. So the monitoring that provides intelligent maintenance, essentially. So, and through there, really, we've ended up with what we call process intensification, which is essentially trying to reduce the equipment count on board. Key reasons for doing that is to really improve the maintainability of the facility, and frankly focusing on selecting reliable equipment and less of them, reducing redundancy where possible, reducing the equipment count. The net result of that is you end up with smaller facilities, more compact, that are easier to maintain. And the sort of net result of that, once you've gone through the starting point of your philosophies, use the enabling technologies as a global design where you've really consolidated and shrunk down the facility as far as possible. You've got a simple solution, which is a lean design. So in terms of life cycle costs, we're able to reduce the CapEx, reduce the OpEx, deliver the same functionality that's required, and overall achieve a sort of low life cycle solution. Just to sort of introduce you to floating NUI, what are we talking about? This is a single column floater. The reason why we focused on a floating facility was to make it usable and accessible for a range of water depths. If we could have done all of the same sort of facilities on a fixed platform, but then we'd have been constrained in the water depth that we could use this. Now the design is scalable. So we've actually delivered concept designs from 100 tons payload all the way up to 5,000 tons payload. And that, when we get onto some of the applications that we're looking at in the next couple of slides, is really useful in terms of being able to look at different applications for different sort of field concepts as we look at the sort of move to net zero. A couple of other sort of key sort of features around this that are aligned with our philosophy. We've designed it so that it can be built pretty much anywhere in the world. The hull is a very simple construction. It can be launched vertically at a quayside of less than 5 meters, so we've got no sort of constructability issues. and it's a low-cost installation and mating. The top sides is built separately to the hull and installed via float-over operation, so we don't use any large cranes. That reduces the capex associated with the installation and mating process. This design here is very much designed for minimal motions in harsh environments, sort of focused on that sort of northern North Sea condition. And really, the design is agnostic of water depth. You know, when it's a floating facility, and really it can be used anywhere from 50 meters water depth up to the deepest fields that we've seen so far. In terms of the use of other technologies, we're using simplified mooring connectors and midline tensioners in the mooring system, which removes the need for fair leads, winches, etc. on the buoy, and subsequently reduces the equipment count and reduces the maintenance through life. So the philosophy, whether it's in the top sides or whether it's in the hull, is to really drive down the overall maintenance of the facility. In terms of sort of how it's sort of operated, we've designed all of the facilities for remote operation and to be maintained on a campaign basis. So if a piece of equipment can't be remotely operated and it can't be maintained infrequently on a campaign basis, then it won't get selected for this facility. By using a walk-to-work vessel to access the facility for maintenance, we can move all of the management and welfare facilities from the offshore facility onto the walk-to-work vessel, and that reduces down the scale of the facilities further. And that's really the trick, is once we get into selecting the right equipment and you know, really sort of focusing on a maintenance-driven design, we can design out a lot of the equipment that you have on a traditional facility that's focused on personnel welfare, because a lot of that is now transferred and provided on the walk-to-work vessel instead. So ultimately, we have a minimum facilities design philosophy, is digitally enabled, and sort of key sort of points in here is achieved AIP, acceptance in principle, from Lloyd's Register, and that was provided as part of the Facility of the Future study. So what's the, you know, these are small, compact, remotely operated facilities that are maintained on an infrequent basis. So what does that mean in terms of the greenhouse gas emissions? So this is a new type of facility. What does that do? Well, number one, it's compact and it can be built pretty much anywhere. So that means that instead of shipping this unit around from Korea or Southeast Asia to the North Sea, you could build this in Europe, you could build this in the UK. So local construction reduces the transportation emission, the emissions associated with transporting the facility to the North Sea. Compact facilities, we're fundamentally using less steel, less material, less equipment, and that reduces the Scope 1 emissions through construction. What else is there? Well, let's think of this in terms of if this was replacing an umbilical, for instance. So it's a power and control buoy, and it's providing the power, control, communications that would otherwise be provided by an umbilical. In that instance, actually, the installation of this is significantly simpler than the installation of the umbilical. If you've got 30 kilometers of umbilical installation, you've got 30 vessel days plus installing that umbilical on the seabed. And what you're doing is reducing those installation emissions, the emissions during that installation process. Similarly, if we look at this in terms of the decommissioning, compare this with the fixed structure. The decommissioning of this facility is significantly lower emissions in that sort of in the decommissioning phase. What else are there? Operating emissions. Well, there's a lot in here. There's the general sort of lean facilities, the reduced equipment count, which ultimately result in lower power demands and lower emissions if they're provided by hydrocarbon sources. Unmanned operations means we're not providing the utilities required to keep personnel safe and in a working environment offshore. That reduces our operating emissions. We're minimizing our maintenance, and when we do carry out maintenance, we carry it out through walk-to-work campaigns rather than providing personnel in a helicopter. So we've reduced the transportation emissions associated with those personnel. And we've reduced the personnel days offshore, which further reduces the emissions. Certainly for the power and control buoys, with much lower power demands, we're increasingly using renewable power options, sometimes supplemented by diesel generators, but ultimately that reduces down the operating emissions of the facilities compared with the traditional solution. And the other sort of key sort of impact here is where we've been developing this as a floating substation, enabling power import from onshore facilities to offshore facilities as the go-between, essentially between the renewable onshore power generation and the offshore facilities. And there you're essentially using this sort of facility here to eliminate the offshore emissions offshore from hydrocarbon production. And finally, so the key point here is this is a floating facility. It's redeployable. We can move this around. We can move it from field to field. So we can access that circular economy that a lot of our offshore hydrocarbon production units really don't. So the fact that we can reuse this, for instance, maybe on sort of short duration tiebacks, maybe 10-year tiebacks, you could use this power buoy to support 2 10-year tiebacks, for instance, within its design life. So being able to access that circular economy means that we can really reduce the emissions per development. What are the applications?
David, just jump in. That's 20 minutes. So
okay, nearly there. Sorry, I'll whiz through the last 5 minutes. Oh, it's typical. It's like we're in Aberdeen all over again. Right. Applications where we see this: supporting challenging tiebacks, so power control, communications, pre-processing, reservoir support, so water injection, and full production, that production buoy that we've been developing with Facility of the Future. And on the other side, the applications we're increasingly talking to clients about: floating substations. We've done quite a lot of work recently to develop this into a floating substation, and carbon dioxide injection. So using this to power subsea wells to inject carbon dioxide subsea. So those are sort of the real applications for this sort of technology as we move forwards. How do we stack up in terms of greenhouse gas emissions? I've probably touched on this already, but I'll just sort of pull out the highlights. Power and utility host, replacing the umbilical for a subsea tieback. The interesting thing here is we can provide subsea control, power generation, chemical storage and injection, communication to the shore, and eliminate an umbilical. So we're eliminating the installation emissions for that umbilical. We're eliminating the cost to construct that umbilical, but replacing it with a power buoy. But we can provide renewable power sources from that buoy. So we can reduce the operating emissions from the buoy for that power control. We're not a manned facility, so all of those, if you're replacing an umbilical from a host facility, then you're replacing the emissions from that host facility. So all of those emissions from that host facility are not being used to develop that tieback. The production buoy, really the focus here is that we're developing small fields with a small unit. So the real focus is that we've reduced down all of our emissions through construction through to operations by being smaller and more efficient. And in terms of the substation, that's where we're actually using this technology to eliminate all of the operating emissions from hydrocarbon production units. So apologies for running over, Nikki. I do, as I've heard those words before. Right. The conclusions here, apologies, it is a bit of a whiz through, but number one, the macro and micro context, the energy transition, the pandemic is driving us towards having to change the way we do things. So we need new development concepts offshore. In the shorter term, increasing the use of renewable power sources. In the longer term, or medium to longer term, electrifying offshore assets. In the very long term, it'll be removing the hydrocarbon production and really focusing on renewables. The focus on emissions is growing, It's going to determine whether projects move forwards, whether they're financeable, but it needs us to focus on offshore efficiencies. And a lot of that is focusing on, well, where do those emissions come from and what can we do to change things? So, I mean, essentially it's doing more, or doing what, you know, providing the functionality offshore that we need with fewer emissions. We see the opportunity there by developing units that are more compact, more efficient with their emissions, focusing on operational efficiency, using people effectively, transporting people effectively, all focusing on that sort of emissions reduction and maximizing the utility of our units. You know, if we design something for a 25-year life and we put it on a field for 10 years, let's use it again for another 10 years. Let's access that circular economy. Now, our point is, through what we've been developing as BPT, through the work we've done with on the Facility of the Future study, we've already developed these compact, these unmanned units that really access a lot of those opportunities for the future. And we really see the application of these units really contributing to our move from today through to net zero. And that is me. Thank you very much for your time.
Thank you very much. It's not having that big screen actually counting down those 20 minutes. That's
I don't remember ever being on time in the hub, to be honest.
Yeah, thank you very much. Obviously there's a lot to cover. This has been sort of like as we say, 2-3 years in the making, and there's been certainly considerable changes, I would say, over the last year, as not just the projects progressed, but as the industry itself has progressed. So we do have a couple of questions that have come up. What I will do is I will run through them and I will unmute you, or Hannah will actually unmute you as we go through. So Paul Dugan, you had a question. If you're happy to ask it, then please feel free to go ahead.
I have unmuted him, but I don't know if it's working, so you might have to just read out his question.
Okay. Right, I will read it out then. It says, when you talk about medium and long-term timeframes, can you quantify these?
Yeah, I think, no, I did think that at the time. If I just pop up to that slide, it's probably easier just to, am I still sharing this? Probably.
Yes, you are.
Yeah, so medium term, the electrification of hydrocarbon production is probably the sort of key one to focus on there. The realistic sort of delivery time for those sort of large scale electrification is probably up to sort of five-year project from pretty soon, really. So that medium term is sort of in the sort of 5 to 10 years, and the long term is going to be the sort of 15 to 20 years plus, isn't it? That's the way I see it. I mean, if you disagree, please do jump in.
Thanks. Hopefully that answered the question. Continue to put anything in the chat, or if you want us to come to you, you can put your hand up as well. Is that possible, Hannah?
Yes, it is.
Okay. So that's Paul coming back. Specifically, I'm interested in your view of offshore hydrogen being a medium-term opportunity. Is that credible?
So yeah, I mean, it's a good question. So what I've got there is introducing offshore hydrogen, and is it credible? Well, there's certainly a platform in the Danish sector at the moment that's powered by offshore hydrogen generated by an offshore wind turbine floating on the semi-sub. I think it's the Harold platform. So am I saying we're going to have whole-scale offshore hydrogen generation? No, I don't think so, not in that time frame at all. I think it'll be decades further down the line. But are we looking at introducing it? You know, are the pilot studies going on today? Yes, there are. So to me, in the medium term, that will be a growing area. I don't think it will be a solution.
Excellent, thank you. So we'll try again, see if we can get anyone to ask a question out loud. So I'll go to, excuse the pronunciation, Bonaprakasa. If you will unmute you if you want to ask your question, and if it doesn't come across, then I'll ask it.
Yeah, thank you. You pronounced it excellent.
Oh, good.
Thank you for great presentations. I'm just wondering about for such, I would say, future, what are the digital enablers that you are requiring? Is there anything that in the pipelines that you are working on? What sort of, if you could actually throw it out to the people that are working on digital technology, what sort of technology that we need to sort of build on to help you?
That's a really good question. I think one of the key findings from the Facility of the Future study, which was focused on the production buoy, unmanned remotely operated production buoy, was that actually from a digital perspective, the tools are available. There's a need for the industry to learn how to deploy the tools and to really sort of embrace the unmanned operations. But we haven't identified any gaps in terms of digital tools or automation that would prevent us necessarily operating a facility on an unmanned basis, especially the sort of simple production facilities or simple power and control. So no, we don't see any barriers there other than the sort of cultural issues we see with projects and operators not necessarily wanting to make large steps in the change to how they operate and maintain facilities from the traditional model. That said, increasingly the story's changing. You know, if you'd have said to me 2 years ago, are operators really sort of willing to embrace unmanned operations, then I think I'd have probably said no. But increasingly with some of the work we're doing, I'm seeing operations teams really interested and really sort of engaging with it in the early stage, and very proactively saying, well, you know, we see this as the future and we see this as needing to be in our projects today. I hope that answers your question.
Yeah, thank you.
So next question we have is from Charlie.
Hello. Thank you for that. That was really, really interesting. I was just wondering, sort of following on from actually the previous question, but applying it, you know, a bit more broadly, you know, from the work that you guys have done, are there any like real technology gaps to building, you know, a floating NUI, and you know, both from a sort of individual technology point of view or a kind of system integration of several technologies, if that makes sense?
No, I don't think so. There are challenges. For instance, the sort of one of the key findings from Facility of the Future was that if for the production buoy, how we deal, because these are small units producing marginal fields, the gas volumes in a marginal field at low production rates really is a sort of nuisance gas volume. And what you do with that gas is a real challenge, because the cost of compressing the gas and exporting it through a pipeline is pretty high. And so economically, that's a challenge for a small field. And also the technologies for small gas compression are not as, you know, frankly not that reliable compared with sort of large scale hermetically sealed gas compression solutions. So I guess it's not really a barrier for all unmanned facilities, but it is a challenge for the development of marginal fields. Will be how we deal with nuisance gas volumes. Now there are options. There's, for instance, a gas to wire approach. There's sort of low pressure sharing of gas between localized units in a sort of area development plan. There are a number of ways you can do it, but what you do with gas on a production facility is probably one of the bigger challenges for unmanned production units. When you look at the replacing an umbilical with power control communications on a buoy, no, I don't see any barriers there whatsoever. I think that's all proven technology. In fact, it's a proven user case. There have been two unmanned floating units which have powered subsea developments. You've got the Mossel Bay subsea tieback, and also the East Spar condensate field as well. So both of those have been developed on that basis. So no, I don't see any issues there.
Oh, interesting. Thank you.
Excellent. Thank you. So we've got time for one more question, I think, if anyone has one. But it was really just to sort of like let you know that if you need any more information, you can get in touch with either David or myself. There's an awful lot of work behind this, and you can imagine that, or you can probably get the message that David can talk about this for quite a while. So we have done quite a few presentations in this area, but as I said, it's continually developing. So it might be something that we'll actually run another event along this line and on this subject in the future. So I see Steve Brown has a question just now. So Steve, are you able to?
There we go. Hello. Hi, David.
Hi, Steve.
I'm looking at all this. I think it looks really good, really interesting. And I've got one simple question is, how much will it cost? So have you done any order of magnitude cost estimates, say for a 10,000 barrel a day oil production buoy?
Yeah, I do. The problem is the question is how long is a piece of string. We've worked up cost estimates.
2.5 feet.
Sorry?
2.5 feet.
Yeah, 2.5 feet. Well, you'll get a 2.5 feet answer. Yeah, what we've seen on the production buoy for Facility of the Future, we costed up it was more like 20,000 barrels of oil a day.
Right.
To be honest, I haven't got the capex per barrel and opex per barrel figures on the top of my head, but it's quite a big step down from a manned sort of floater, manned sort of FPSO equivalent. But I haven't got the numbers on the top of my head. The other thing is there are so many variables in there. For instance, the gas compression.
Yeah.
What do you do with the gas? That giving you a generic number will always be wrong. So I'd rather not, if that's okay. But very happy to take it offline, Steve. So if you've got a field application in mind, we could cost something up pretty easily.
Oh, I've I've got a field.
I know.
I won't say which one, but
no, obviously not.
Not my main one. Not my main one.
Okay. But no, yeah, we could certainly work something up for you. But the other side of it is the power and control buoy powered subsea tiebacks offer a really interesting new development solution. Where there are stranded fields that are a little bit bigger, a little bit more challenging, a little bit more remote, that a subsea tieback looks difficult, but a production unit isn't going to be economically viable. That's where we see the real value in putting a small utility buoy on the field. We're seeing a lot of operators in the US talking about what they call a hub and spoke strategy, where they're really looking to maximize the use of their existing hubs by tying in incremental resource from further and further away.
Yeah.
We've also seen that in West Africa. And I think as we look at the North Sea, as decommissioning accelerates and increases, then we're going to have fields that were close to infrastructure, didn't get developed, and are now remote. And it's those fields that you look at, or fields that have been abandoned with oil in place because the downstream infrastructure is being decommissioned. And that's where we could see a scenario where these sort of longer range subsea tiebacks supported by a little power buoy is a really low risk and economically attractive way forwards. And just sort of briefly expanding on that, where, and on that sort of the access to finance challenge, if you've got a predominantly renewably powered subsea tieback, which is lower capex because you're not putting in a full production facility, you're maximizing the use of existing production facilities. It's renewably powered. It's using the it's reusable in the future once your field life's used up. Well, to be honest, that's going to be easier to finance, and it's more likely to move forwards. The risk profile should be lower than putting in a whole bunch of new facilities on an economically marginal field.
So do you have a price for the power and control buoy?
Once again, yes, I do. You know, the mini buoy, as we're calling it at the moment, is coming in at about sort of $15 million
Right.
installed. But that's really just providing very simple utilities, chemical injection at the well site. Once we start adding in power for subsea pumping applications, wet gas compression, for instance, the price goes up.
Fair enough, but it's going
once
up.
Again, it depends how long your piece of string is.
Yeah, yeah. 2.5 feet.
That's great. Thank you. I think we'll wrap it up there. We're slightly over time wise, but it was a good discussion. So I just wanted to thank all of you for joining us and asking your questions, and huge thanks to David for presenting today. And as we said, if you want to extend the conversation, you can speak to either David or myself, and we'd be more than happy to set something up with you. So in the meantime, I would like to say keep safe and well, and hopefully we will see you again soon at one of these events. So thank you very much.
Thank you very much, everyone.